Welcome viewers. In this video we'll see the interconnection of two-port network, in that parallel connection of a two-port network. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, parallel connection of a two-port network. So while connecting in parallel or series or cascade, we have to follow the certain procedure to represent the two-port network. First we'll see the what are the procedure available. So when the two-port networks are connected in cascade, then the parameter of the interconnected network can be conveniently expressed with the help of ABCD parameters. So while connecting in cascade, cascade means one type of connection having certain style, then it's called a cascade. In that we can use ABCD parameters. In similar way, the Z parameter can be used to describe the parameters of series connected two-port network. If it is series connected, we can use the Z parameter. The Y parameter can be used to describe the parameters of parallel connected two-port network. Right? So this is the procedure. We know that there are 6 type of two-port networks are available: Z parameter, Y parameter, ABCD parameters, inverse ABCD parameters, hybrid and inverse hybrid. So in that we are using ABCD parameter for cascade connection, Z parameter for series connection, Y parameter for parallel connection. Now we'll go to the topic, parallel connection of two-port network. So now we'll see the parallel connection. So we are going to use the Y parameter for the parallel connection network. So let us consider the two-port network connected in parallel as shown in the diagram. Now we'll refer the diagram. So here the two networks X and Y are connected in parallel. This is the network X, network Y are connected in parallel. So we know that in parallel circuit the voltage will be equal. Same voltage is applied to network X as well as network Y. In the current is nothing but it is a current will be splitted. Then only it is called a parallel network. So here the current will be splitted. So this is the V1, the voltage at the input port. The V1 is applied to X network as well as Y network. Same voltage is applied to X and Y network. So voltage across X and Y network is V1, input port voltage. Similarly, output port voltage V2, the same voltage is available across X network as well as Y network. So V1 equal to V1X, that is equal to V1Y. Similarly, V2 equal to V2X, that is equal to V2Y. Voltages are equal. Then what about the current? The current, input port current is divided into I1X, I1Y, X network and Y network. So I1 is the sum of I1X and I1Y. That is given here. I1 equal to I1X plus I1Y. Similarly, I2 is the sum of I2X and I2Y. So I2 equal to I2X plus IY. During the simplification, we can use this parameter. We can use this relation. So the parallel network, we know that the voltages are equal. Current is divided. So sum of these two current is the total current. Now we'll see the description. If each two-port has a reference node that is common to its input and output port, and if the two ports are connected so that they have a common reference node, then the equation of the parameter, equation of the network X and Y in terms of Y parameters are given. So we can take the reference node so that X and Y network can be expressed in terms of the Y parameter. What is that Y parameter? So this is the general Y parameter. Current, input and output port current are expressed in input and output port voltage. Currents are expressed in terms of voltage. I1 equal to Y11 V1 plus Y12 V2. I2 equal to Y21 V1 plus Y22 V2. I1, I2 is the input and output port current. V1 and V2 is the input and output port voltage. Y11, Y12, Y21, Y22 are the Y parameters. The same thing can be expressed for X network as well as Y network. So we have a reference node. So I1X, so here everything is expressed in terms of X. I1X equal to Y11X plus V1X into V1X plus Y12X into V2X. Similarly, I2X equal to Y21X into V1X plus Y22X into V2X. Right? So everything is expressed in terms of X network. Now similarly, Y network. I1Y equal to Y11Y into V1Y plus Y12Y into V2Y. Similarly, I2Y equal to Y21Y, Y1Y plus Y22Y into V2Y, right? So this is expressed, this is a Y parameter. So general Y parameter is expressed for X network as well as Y network. So we need to analyze why it is connected in parallel. What is the resultant parameter? We need to analyze. Now we'll see what is the resultant parameter. So from the diagram itself, we analyze that from the interconnection of network, when it is parallel, the voltage is equal. V1 equal to V1X, V1Y. V2 equal to V2X, that is equal to V2Y. The current is sum. I1 total current equal to I1X plus I1Y. X network and Y network current is divided. Similarly, I2 equal to I2X plus I2Y. Right. Now we'll see the equation I1 by combining X network as well as Y network. So both are connected in parallel. So based on this, I1 equal to I1X plus I1Y. Based on that, we can write. So I1 equal to, this is the refer the X network, this refer the Y network. In that, the voltages are equal. So we can replace this V1X and V1Y as V1. Similarly, V2X and V2Y can be replaced by V2. Okay, so that it is replaced. Y11X, V1X is V1, V2X is V2, V1Y is V1, V2Y is V2. Right, now it is replaced. Based on the parallel connected network, we have this relation. Now take this V1 common. V1 available in first term and third term. So we can take outside. So Y11X plus Y11Y. Similarly, the V2 available in second term and fourth term. Take outside. So that V12X plus V12Y. Now we got this relation after substituting this voltage equation. Right. Similarly, we can go for a I2, output port current. So here also, this is the X term, X network, this is Y network. Here V1X is replaced by V1, V2X is replaced by V2, V1Y is replaced by V1, V2Y is replaced by V2. Now we'll take the V1 common available in first term and third term. We'll take outside. So Y21X plus Y21Y. Similarly, V2 available in second and fourth term. Take outside. Y22X plus Y22Y. Right. So finally we got this equation. So these two equations we can write it. So Y11X plus Y11Y can be simply written as Y11 because both are X and Y network. So we can write the describing equation for parallel connected two-port network are I1 equal to Y11 V1 plus Y12 V2, I2 equal to Y21 V1 plus Y22 V2. What is that Y11? Y11 is nothing but Y11X plus Y11Y. Y12 is nothing but Y12X plus Y12Y. Similarly, Y21 is nothing but Y21X plus Y21Y. Y22 is nothing but Y22X plus Y22Y. Right? So that is also given here. So this is a relation. So the X network and Y networks are added together. Right. So from that we can easily conclude. What is the conclusion? So we seen that each y parameters of a parallel network is given as the sum of corresponding parameters of the individual network, right? So the each y network is nothing but the sum of the corresponding individual network. So we can add together sum. Why? Because this y parameter is nothing but the currents are expressed in terms of voltage, current. So in parallel network, automatically the current is sum of the two network. The current is divided into two networks. So the total current equal to current flowing through X network and Y network. So that we are using this Y parameter. In case of series connected network, we are using the Z parameter, because the voltage will be sum. Total voltage equal to voltage across the X network and Y network. V equal to V1 plus V2. So that we are using Z in series connection. Here currents are the sum. The current is the sum of the individual current. So that we are using the Y parameter. So in this video we discuss interconnection of two-port network while connecting the parallel connection of network. So this is expressed in terms of Y parameter. Finally we got that individual Y parameter is the sum of the each Y parameter is the sum of the individual Y parameters. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.